OpenStreetMap is a collaborative project to create a free editable map of the world. Two major driving forces behind the establishment and growth of OSM have been restrictions on use or availability of map information across much of the world and the advent of inexpensive portable satellite navigation devices. OSM is considered a prominent example of volunteer geographic information. Created by Steve Coast in the UK in 2004, it was inspired by the success of Wikipedia and the preponderance of proprietary map data in the UK and elsewhere. Since then, it has grown to over 2 million registered users, who can collect data using manual survey, GPS devices, aerial photography, and other free sources. This crowdsourced data are then made available under the Open Database license. The site is supported by the OpenStreetMap Foundation, a non-profit organization registered in England and Wales. Rather than the map itself, the data generated by the OpenStreetMap project are considered its primary output. The data are then available for use in both traditional applications, like its usage by Craigslist, Osmond, Geocaching, MapQuest Open, JMP statistical software, and Foursquare to replace Google Maps, and more unusual roles like replacing default data included with GPS receivers. This data have been favorably compared with proprietary data sources, though data quality varies worldwide. History. Steve Coast founded the project in 2004, initially focusing on mapping the United Kingdom. In the UK and elsewhere, government-run and tax-funded projects like the Ordnance Survey created massive datasets but failed to freely and widely distribute them. In April 2006, the OpenStreetMap Foundation was established to encourage the growth, development and distribution of free geospatial data and provide geospatial data for anybody to use and share. In December 2006, Yahoo! Confirmed that OpenStreetMap could use its aerial photography as a backdrop for map production. In April 2007, Automotive Navigation Data donated a complete road dataset for the Netherlands and trunk road data for India and China to the project, and by July 2007, when the first OSM International The State of the Map conference was held, there were 9,000 registered users. Sponsors of the event included Google, Yahoo! And Multimap. In October 2007, OpenStreetMap completed the import of a U.S. Census Tiger Road dataset. In December 2007, Oxford University became the first major organization to use OpenStreetMap data on their main website. Ways to import and export data have continued to grow. By 2008, the project developed tools to export OpenStreetMap data to power portable GPS units, replacing their existing proprietary and out-of-date maps. In February 2008, a series of workshops were held in India. In March, two founders announced that they have received venture capital funding of €2.4 million for CloudMade, a commercial company that uses OpenStreetMap data. In 2012, the launch of pricing for Google Maps led several prominent websites to switch from their service to OpenStreetMap and other competitors. Chief amongst these were Foursquare, Craigslist, who adopted OpenStreetMap, and Apple, which ended a contract with Google and launched a self-built mapping platform which uses TomTom and OpenStreetMap data. State of the Map. Since 2007, the OSM community has held an annual, international conference, the State of the Map. Venues have been 2007 Manchester, UK, 2008 Limerick, Ireland, 2009 Amsterdam, Netherlands, 2010 Girona, Spain, 2011 Denver, USA, 2012 Tokyo, Japan, 2013 Birmingham, UK, 2014 Buenos Aires, Argentina, 2015-2016 Brussels. Map production. Map data is collected from scratch by volunteers performing systematic ground surveys using tools such as a handheld GPS unit, a notebook, digital camera, or a voice recorder. The data is then entered into the OpenStreetMap database. More recently, the availability of aerial photography and other data from commercial and government sources has added important sources of data, both for manual editing and automated imports. Special processes are in place to handle automated imports and avoid legal and technical problems. Software for editing maps. Editing of maps can be done using the default web browser editor called ID, an HTML5 application using D3.js and written by Mapbox. The earlier Flash-based application Potlatch is retained for intermediate-level users. OSM and Mercator are more powerful desktop editing applications that are better suited for advanced users. Contributors. The project has a geographically diverse user base. Due to emphasis of local knowledge and ground truth in the process of data collection, many early contributors are cyclists who survey with and for bicycles, charting cycling routes and navigable trails. Others are GIS professionals who contribute data with Esri tools. By August 2008, shortly after the State of the Map conference was held, there were over 50,000 registered contributors. By March 2009, there were 100,000 and by the end of 2009 the figure was nearly 200,000. In April 2012, OpenStreetMap cleared 600,000 registered contributors. On 6 January 2013, OpenStreetMap reached 1 million registered users. Around 30% of users have contributed at least one point to the OpenStreetMap database. Surveys and personal knowledge. Ground surveys are performed by a mapper, on foot, bicycle, or in a car, motorcycle or boat. Map data are usually collected using a GPS unit, although this is not strictly necessary if an area has already been traced from satellite imagery. Once the data has been collected, it is entered into the database by uploading it onto the project's website. At that point, no information about the kind of uploaded track is available. It could be e.g., a motorway, a footpath, or a river. Thus, in a second step, editing takes place using one of several purpose-built map editors. This is usually done by the same mapper, sometimes by other contributors registered at OpenStreetMap. As collecting and uploading data is separated from editing objects, contribution to the project is possible also without using a GPS unit. In particular, placing and editing objects such as schools, hospitals, taxi ranks, bus stops, pubs, etc., is done based on editors' local knowledge. Some committed contributors adopt the task of mapping whole towns and cities, or organizing mapping parties to gather the support of others to complete a map area. A large number of less active users contribute corrections and small additions to the map. Government data. Some government agencies have released official data on appropriate licenses. Much of this data has come from the United States, where works of the federal government are placed under public domain. In the United States, OSM uses Landsat 7 satellite imagery, prototype global shorelines from NOAA, and Tiger from the census. In the UK, some Ordnance Survey open data is imported, while Natural Resources Canada's CamVec vector data and GeoBase provide land cover and streets. Out-of-copyright maps can be good sources of information about features that do not change frequently. Copyright periods vary, but in the UK Crown copyright expires after 50 years and hence Ordnance Survey maps until the 1960s can legally be used. A complete set of UK 1-inch/mile maps from the late 1940s and early 1950s has been collected, scanned, and is available online as a resource for contributors. Route planning. In February 2015, OpenStreetMap added route planning functionality to the map on its official website. The routing uses external services, namely OSRM, Grasshopper and MapQuest. There are other routing providers and applications listed in the official routing wiki. Map usage. Software for viewing maps. Web browser. The most obvious software to employ to make use of the data provided by the OpenStreetMap project. is to view it in any ordinary web browser via Hypertext Transfer Protocol. GNOME Maps is a graphical front-end written in JavaScript and introduced in GNOME 3.10. It provides a mechanism to find the user's location with the help of GeoClue, finds directions via Grasshopper, and it can deliver a list as answer to queries. Marble received support for OpenStreetMap Foxtrogs. Foxtrogs is a GTK+-based map viewer that is especially suited to touch input. It is available in the SHR or Debian repositories. Emerald, another GTK+-based map viewer. The website OpenStreetMap.org provides a Slippy map interface based on the Leaflet JavaScript library, displaying map tiles rendered by the Mapnik rendering engine, and tiles from other sources including OpenCycleMap.org and MapQuest. Open maps can also be generated offline by a local installation of Mapnik and downloaded map data. OpenStreetMap maintains lists of online and offline routing engines available, such as the open-source routing machine. The OSM data is popular with routing researchers, and is also available to open-source projects and companies to build routing applications. Humanitarian Aid. The 2010 Haiti earthquake has established a model for non-governmental organizations to collaborate with international organizations. OpenStreetMap and Crisis Commons volunteers used available satellite imagery to map the roads, buildings and refugee camps of Port-au-Prince in just 2 days, building the most complete digital map of Haiti's roads. The resulting data and maps have been used by several organizations providing relief aid, such as the World Bank, the European Commission Joint Research Centre, the Office for the Coordination of Humanitarian Affairs, UNOSAT, and others. NGOs, like the Humanitarian OpenStreetMap team and others, have worked with donors like USAID to map other parts of Haiti and parts of many other countries, both to create map data for places that formerly were blank, and to engage and build capacity of local people. After Haiti, the OpenStreetMap community continued mapping to support humanitarian organizations for various crises and disasters. After the Mali disaster, Typhoon Haiyan in the Philippines, and the Ebola virus epidemic in West Africa, the OpenStreetMap community has shown it can play a significant role in supporting humanitarian organizations. The Humanitarian OpenStreetMap team acts as an interface between the OpenStreetMap community and the humanitarian organizations. Along with post-disaster work, the Humanitarian OpenStreetMap team has worked to build better risk models for Uganda and elsewhere, in partnership with the Red Cross, World Bank, and other humanitarian groups. Legal aspects. Licensing terms. OpenStreetMap data was originally published under a Creative Commons open content license with the intention of promoting free use and redistribution of the data. In September 2012, the license was changed to the Open Database license from Open Data Commons in order to more specifically define its bearing on data rather than representation. As part of this relicensing process, some of the map data was removed from the public distribution. This included all data contributed by members that did not agree to the new licensing terms, as well as all subsequent edits to those affected objects. It also included any data contributed based on input data that was not compatible with the new terms. Estimates suggested that over 97% of data would be retained globally, however certain regions would be affected more than others, such as in Australia where 24 to 84% of objects would be retained, depending on the type of object. Ultimately, more than 99% of the data was retained, with Australia and Poland being the countries most severely affected by the change. All data added to the project needs to have a license compatible with the Open Database license. This can include out-of-copyright information, public domain or other licenses. Contributors agree to a set of terms which require compatibility with the current license. This may involve examining licenses for government data to establish whether it is compatible. The application, what users access to edit maps and view changelogs, is powered by Ruby on Rails. The application also uses PostgreSQL for storage of user data and edit metadata. The default map is rendered by Mapnik, stored in Postgres, and powered by an Apache module called mod_tile. Certain parts of the software, such as the map editor Potlatch2, have been made available as public domain. Commercial data. Some OpenStreetMap data is supplied by companies that choose to freely license either actual street data or satellite imagery sources, from which OSM contributors can trace roads and features. Notably, automotive navigation data provided a complete road data set for Netherlands and details of trunk roads in China and India. In December 2006, Yahoo! Confirmed that OpenStreetMap was able to make use of their vertical aerial imagery, and this photography was available within the editing software as an overlay. Contributors could create their vector-based maps as a derived work, released with a free and open license, until the shutdown of the Yahoo! Maps API on 13 September 2011. In November 2010, Microsoft announced that the OpenStreetMap community could use Bing vertical aerial imagery as a backdrop in its editors for a period from 2009 to 2011. Nearmap Pty Limited made their high-resolution photo maps available for deriving OpenStreetMap data under a CC by SA license operation. While OpenStreetMap aims to be a central data source, its map rendering and aesthetics are meant to be only one of many options, some which highlight different elements of the map or emphasize design and performance. Data format. OpenStreetMap uses a topological data structure, with 4 core elements. Nodes are points with a geographic position, stored as coordinates according to WGS84. Outside of their usage in ways, they are used to represent map features without a size, such as points of interest or mountain peaks. Ways are ordered lists of nodes, representing a polyline, or possibly a polygon if they form a closed loop. They are used both for representing linear features such as streets and rivers, and areas, like forests, parks, parking areas and lakes. Relations are ordered lists of nodes, ways and relations, where each member can optionally have their role. Relations are used for representing the relationship of existing nodes and ways. Examples include turn restrictions on roads, routes that span several existing ways, and areas with holes. Tags are key-value pairs. They are used to store metadata about the map objects. Tags are not freestanding, but are always attached to an object, to a node, a way or a relation. A recommended ontology of map features is maintained on a wiki. Data storage. The OSM data primitives are stored and processed in different formats. The main copy of the OSM data is stored in OSM's main database. The main database is a PostgreSQL database, which has one table for each data primitive with individual objects stored as rows. All edits happen in this database, and all other formats are created from it. For data transfer, several database dumps are created, which are available for download. The complete dump is called planet.osm. These dumps exist in 2 formats, one using XML and one using the protocol buffer binary format. The link geodata data uses the geospec and well-known text RDF vocabularies to represent OpenStreetMap data. It is a work of the Agile Knowledge Engineering and Semantic Web Research Group at the University of Leipzig, a group mostly known for DBpedia. Commercial services. A variety of popular services incorporate some sort of geolocation or map-based component. Notable services using OSM for this include Applink, unexpectedly created an OpenStreetMap-based map for a photo for iOS on 7 March 2012, and launched the maps without properly citing the data source, though this was corrected in 1.0.1. OpenStreetMap is one of the many cited sources for Apple's custom maps in iOS 6, though the majority of map data is provided by TomTom. Flick uses OpenStreetMap data for various cities around the world, including Baghdad, Beijing, Kabul, Santiago, Sydney, and Tokyo. In 2012, the maps switched to use Nokia data, primarily, with OSM being used in areas where the commercial provider lacked performance. MapQuest announced a service based on OpenStreetMap in 2010, which eventually became MapQuest Open. On 29 February 2012, Foursquare started using OpenStreetMap via Mapbox's rendering and infrastructure. Craigslist also switched to OpenStreetMap in 2012, rendering their own tiles based on the data. In 2015, MapWorks incorporated the OSM dataset for rendering under a vector publication method. This allows basic GIS analysis capabilities to be performed at web clients supporting HTML5. In 2009, Hasbro, the games company behind the property trading board game Monopoly, launched Monopoly City Streets, a massively multiplayer online game which allowed players to buy streets all over the world. The game used map tiles from Google Maps and the Google Maps API to display the game board, but the underlying street data was obtained from OpenStreetMap. The online game was meant to be a limited-time offering, closing at the end of January 2010. MoveIt uses maps based on OpenStreetMap in their free mobile application for public transit navigation. Pictometry uses OpenStreetMap as the default map in their web-based products for displaying their patented 3D aerial photography. Wikipedia uses OpenStreetMap data to render custom maps used by the articles. Many languages are included in the WIWOSM project, which aims to show OSM objects on a slippy map, directly visible on the article page. Wikivoyage uses OpenStreetMap as a locator map for cities and travel points of interest. Dublin-based indie games developer Balladia launched World of the Living Dead: Resurrection in October 2013, which has incorporated OpenStreetMap into its game engine, along with census information to create a browser-based game mapping over 14,000 square kilometers of Greater Los Angeles and survival strategy. Gameplay. Its previous incarnation had used Google Maps, which had proven incapable of supporting high volumes of players. So during 2013 they shut down the Google Maps version and ported the game to OSM. Geotab uses OpenStreetMap data in their vehicle tracking software platform, MyGeotab.